When we are making a robot, we have an idea because of the design that we have already done. But for a simulation, the computer doesn't know what is the structure of the robot. So we have to tell by ourselves what is going to be the basic structure, how things are going to be connected within the robot structure. There are two major things when we are making a robot: joints and the links. In our case, joints are the points where motion happens. Links are the bodies that connect those joints. In this example of our robot, you can see this whole thing is known as a link. It is not producing the motion, although it is rotating, you will see, but it is a body that is connecting this point which is rotating on the z-axis and this point which is further going to produce a rotation. So this blue bar is a link and we have a red circular joint which is going to produce the motion. So this was links and joints. Now we have the question again remaining unsolved: which point makes the robot simulation, which what makes the simulation understand the structure of the robot, right? The transform is the concept which is utilized. For example, in our case, we have this circular base on which we have this bar. Now this bar is a link, circular point, the first is known as the base which we have created, but this is what we know. The simulation does not know that. So transforms are utilized to produce a structure within a robot. There is going to be a difference in XYZ from base to the link number 1. This is link number 1, and that is going to be defined through a transform. For example, this base is on the origin, meaning origin is 0 0 0 in XYZ and the base is again 0 0 and let's say 0.1 in z-axis, a little bit up in the z-axis. So this point from world to base, we have a transform. Whenever we move the world, this base is also going to move with an offset of 0.1 on the on the z-axis. This is known as the transform between two things. Now whole of the robot structure is produced with the same strategy. Link number 1 is on the base. There is no difference in their origins, the place where they are placed. But we have this link number 2, which is a joint and it rotates along a certain axis, but it is located at a point of 0 in x, 0 in y, and 1.2 in z-axis. Now this 1.2 in z-axis is from base. Okay, this is a transform between link number 1 and link number 2. When we move this world, base is going to be moved and this link number 2 is also going to be moved because we have a specific transform, a structure in between these links and joints. So this is the basic concept of transforms, which is utilized to keep the robot in a structure. Now coming to the point of actuated and non-actuated joints. We have certain joints which are fixed, they are not moving, those are known as non-actuated. For example, this base is never going to be moved, is never going to move. It is fixed with the world. You will see it is directly written. This joint is fixed, this link is fixed. So world and base are fixed, although there is an offset, but they are not going to move. In our case, this link number 2 here, this red circular uh, joint is a rotational joint. It is rotating along this axis. Same goes for this one, link number 4. It is going to rotate. This link number 3 and link number 1 are fixed joints. They are not going to be actuated. Actuated means producing a motion. So link 2 and link 4 are going to be rotating. So they are actuated and those blue bars are non-actuated. They are fixed. Coming to the last thing, parent and child. Parent and child in links and joints. These are going to create a structure for the robot to make the simulation understand what a robot looks like. Although these words are messed up, we'll see in the RWAs what actually they are saying. You can see there is some sort of an arrow coming from each of a point to another. Now you can see from link number 4 to link number 3, this arrow is going outside of 4 and going inside or to a point in link number 3. This is representing that link number 3 is actually the parent and link number 4 is the child. So we have to define the structure of the robot in a parent-child relation. Similarly, we have a lot of things at this point. Base link, world and link number 1 all are written at the same point because there is very small offset. We'll look into link number 2. Link number 2 is child because this arrow is coming out of link number 2 to link number 1. So link number 1 is parent, and for link number 1 base is parent. For base, world is parent. So that's how a structure has been created, and which gives a meaning to your robot's definition for the simulation. We'll see into the URDF now to understand better what is happening, how the structure is being created. Let's take a look.